In this video, we're going to factor this polynomial using long division and synthetic division to be able to compare the two methods. And we'll see that we still get the same result, but having them side by side, I'll see the different processes. Here's our polynomial. First thing we need is to use the factor theorem to be able to find the first factor that we're going to use in the long division. To do that, we take the back number and the front number, so 6 over 2, and we can use any factors of 6 and 2 in a ratio to test in the polynomial to find 0. So I'll show you what I mean. The factors of 6 are plus or minus 3, plus or minus 2, plus or minus 1, and plus or minus 6. Over, for 2, there's plus or minus 1, plus or minus 2. So any combination of this numerator and denominator, we can plug that in for x, see where we get 0, and that'll give us our factor that we're going to divide in. So this could take a little while, but hopefully we can kind of do it fairly quickly. I'm going to always start with 1 and negative 1. That's a good way to test. So I'm going to plug in 1 for x. Remember, we're trying to make this thing equal to 0. Squared minus 11, 1 plus 6. That equals 2 minus 3 minus 11 plus 6. That does not work. So positive 1 does not work. What if I made these negative ones? Negative 2 minus 3 is negative 5, plus 11 is positive 6, plus another 6, also not 0. So plus or minus 1 does not work. So I can get that out of here. What about plus or minus 2? So 2 over 1. Let's try that. 2 into 2 cubed minus 3, 2 squared minus 11 times 2 plus 6. What does that equal? This is 16 minus 3 times 4 is 12, so we're at 4. Minus 22 is negative 18 plus 6. That does not work. What about negative 2? Negative 2, negative 2, negative 2. This is going to be negative 8 times 2, so negative 16. Minus 12 still. Plus 22 plus 6. And then we have negative 28 plus 28. That equals 0. Great. So we found that when we plug negative 2 in, this is what the factor theorem says. We plug negative 2 in for x, the whole polynomial equals 0. That means x plus 2 is a factor. So we're going to divide this by x plus 2, because we know that's a perfect factor that will make the whole thing 0. Now we can do our division to factor the rest of it. So I'm going to show long division first. So x plus 2 into 2x cubed minus 3x squared minus 11x plus 6. Alright, this works just like division does for normal integers or even decimals, numbers without x's in it. We're going to start with the outside term, divide it into the first term, write that on top, multiply it back, and do subtraction. X into 2x cubed goes 2x squared times. I'm going to write that here. It's best if you can keep things in line vertically, especially as it goes x cubed, x squared, x, and then the number. Then I'm going to multiply this back, and we get 2x cubed. 2x squared plus 2 is 4x squared. Then I minus. I like to put brackets around so that we make sure that we carry the negative through when we do the subtraction. 2x cubed minus 2x cubed is 0. Negative 3x squared minus 4x squared is negative 7x squared. Then you just repeat the process. X into negative 7x squared is negative 7x. Multiply it back. Negative 7x squared. And negative 7x times 2 is negative 14x. Here's where we bring down our negative 11x, just like you would in normal division, and subtract again. I'm going to put the subtraction in my brackets. This goes to 0. Negative 11x plus 14x is 3x. Last time, repeat the process. X into 3x goes 3 times. Multiply it back and we get 3x. 3 times 2 is 6 plus 6. Bring this guy down. And this should go to 0, which means there's a 0. There's a remainder of 0 when we divide by x plus 2. And we knew that that was going to be the case because we already tested the factor theorem beforehand. The final step for fully factoring this polynomial is to see if we can factor this quadratic anymore. So right now we're saying x plus 2 times 2x squared minus 7x plus 3. This is the way to rewrite that polynomial, but I can factor this quadratic as well. So the final factoring is x plus 2. This factors into 2x minus 1 and x minus 3. You can do that factoring any way you like, but this will be the fully factored version of our polynomial. Again, this is helpful because we can easily see what the zeros are, what the solution would be if it was equal to 0, things like that. Let's show synthetic division the same way. So again, we're still going to divide x plus 2 in because we use the factor theorem to show that. The key is we take the value for x that made the factor theorem equal to 0. So we don't actually use x plus 2, we use the fact that when we put negative 2 in here, it equals 0. So that's how we set up our synthetic, and we're just going to write negative 2 here. Then I'm going to take the coefficient from each of the different terms. So 2, negative 3, negative 11, and 6. And then we'll see exactly how this works. Again, you should be able to tie it back to the steps in long division. This is just like a nice shortcut. We bring the 2 down first, and then we do negative 2 times 2 is negative 4, and then we add vertically. Negative 3 minus 4 is negative 7. Repeat, negative 2 times negative 7 is 14. Add vertically, negative 11 plus 14 is 3. Negative 2 times 3 is negative 6. Add vertically, that's the big difference, is that we're adding vertically in synthetic versus we were kind of subtracting as we went in long division. 6 minus 6 is 0, so that should also match your remainder. The result are your coefficients of your different terms here. So we started at x cubed, but it's now become, this is now the coefficient on x squared, on x, and the constant. So we can then say that our x plus 2 leaves us with a quotient of 2x squared minus 7x plus 3. So it matches exactly what we had here, and then again you can go and factor your quadratic however you like. 2x minus 1 and x minus 3. So synthetic is actually nice and fast. It does save you a bit of work. As you can see, there's a lot less writing over there. The hardest part about getting started in these questions is actually the factor theorem to find an x value that makes the polynomial equal to 0. That sometimes you can save that step because sometimes the question will just tell you divide x plus 2 in. Hopefully that was helpful. You can always send us more questions to info@arnoldtutoring.com. Thanks.